Hi, we are Team D3 and our work is on electricity consumption and cost prediction for cloud computing. The aim of a project is to predict the electricity cost using machine learning model that is trained with the existing data. The cost prediction allows cloud computing providers to better utilize the resources by scheduling the workloads at off-peak hours, forecast the future demand for the resources, and also minimize the pricing plan that is highly beneficial for the cloud users as well. So the existing work done on this include ML models, CNN, MLNN, XGBoost and many more. But for our implementation, we used ensemble learning techniques that are XGBoost regressor and random forest. So XGBoost regression is a popular gradient boosting algorithm and it is also known for its high performance and parallel computation. While random forest regressor is a bagging method that uses multiple decision trees for the prediction. So this is the use case diagram. We have two actors, the user and the system. User performs actions like registering to the system, logging in, loading the data, viewing this data, and the selection of the model and reviewing the prediction. The system stores, displays the data and the results. And next is the sequence of steps in this activity diagram. The steps performed are the user registers and logs in. The data is stored in the backend in the SQL database. The user loads the data that contains the information about the energy consumed from the various resources in megawatt-hour units. This data is stored at the backend. The user selects the model of choice, either XGBoost or random forest, to predict the cost of electricity consumed. The classes here are the system and the user. It contains the following attributes and the methods. And next is the data flow diagram. We see that SQL interacts between the system and the user. The users share the data and the system processes it. This is the system architecture. It mentions how the users, the system, the database, and the UI interact to give the desired outcome. This is the page the user interacts with. The user need to give the basic details for the registration into the system. After that, he need to log in into the system using the registered credentials. We already have a registered user. We log in using the same credentials. Now the user gets validated and he could load the data and select the model. We are loading the data here. We already have a data CSE file that is collected from Spain. So after loading data is successful, we get to view this data. We see all of the energy resources and the energy consumed from these resources and the actual price, the cost of the electricity at that particular hour. Now we get to select the model, the random forest or the XGBoost. At first, we'll select the random forest regressor and check the model prediction. So the R2 score of a random forest regressor is 89.55. Now for the XGBoost regressor, the R2 score is 90.11. So the XGBoost regressor is a better performer. Now we can also predict the electricity cost directly using the values that are given for each of the energy resources. Now for the given input, the predicted cost is 65.9 euros. Then after that, user can log out of the system. This is the system the user interacts with to predict the cost for the electricity consumed. So to conclude, we saw that the electricity consumption for the cloud resources using some of the ML models benefit both the providers and users. In addition, we also need to continuously monitor and update the ML models to make sure that the prediction remain constant and accurate over time. Thank you.